Hello, am I audible? Hello, hello, am I audible, guys?
Yes, sir.
Okay,
Yes, sir.
okay. So I request if anyone is new to this session, I request to please introduce themselves. Anyone who is new to this session, kindly please introduce. Bikram Nahak, can you unmute yourself? Yes, Sadasiva Pradhan, please.
Yes, sir.
Yes, can you introduce yourself?
So my name is Vasif Pradhan. I'm from IMIT Odisha.
Okay, very nice. Anyone else who wants to introduce? Okay, so let me start the session. I hope no one wants to introduce. So let me present. So is my slide visible to all of you, guys? Okay.
Yes, sir.
Okay, so let me start the week 4 discussion. I have already taken 3 week discussion before this, and let me again introduce myself. My name is Ayan Paul. I am a PMRF research scholar from IIT Kharagpur, and I will be taking this course, Introduction to Soft Computing, as a TA. And this course is originally taken by Professor Devasi Samanta of Department of Computer Science and Engineering, IIT Kharagpur. So let me begin. So today, from last class, I have ended the fuzzy theory discussion, and we have just stepped in GA. And today we will be knowing more detail about this GA. GA is genetic algorithm. So I will be starting our session, by introducing you with some GA elements. So genetic algorithm uses two distinct terms. One is your individual and another one is population. So individual, by name only you can understand, individual is a single solution, while population set of individuals. Now we are interested in knowing what exactly is in an individual. So in GA, an individual consists of two terms. One is genotype and another one is phenotype. So what is this genotype? So when we are dealing with some problem, like any engineering problem, we have some variables like input variables like x1, x2, x3, x4, etc. This is known as genotype in individual of genetic algorithm. And what is phenotype? Now each individual genotype consists of DNA, and this DNA is made up of chromosomes. Chromosomes can be string of alphabets or numbers or symbols, anything. So this DNA of a genotype is known as phenotype. So is this clear to all? Guys, first slide. Anyone having any doubt regarding individual, population, genotype, phenotype? Hello? Am I audible?
Yes, sir.
Okay, so guys, I want you to participate in the discussion, otherwise it will not be very interesting. Okay, so if I will be talking from one end and you will just listen, so that will not be an interactive session. So I encourage you all to please participate in the discussion, and you can participate by either unmuting yourself or writing in chats. So today the population is also very less, so we have only 10 participants. So kindly write in chats. Okay, so I hope this slide is clear to all, right? Yes? Okay, very nice. So let's move on to the next slide. So now when we are forming a GA code, our computer does not know numbers, right? Our computer know only two numbers, that is 1 and 0. So we have to convert our real value variable into binary codes. So how to do that? So to do that, here I have discussed you factor 1, factor 2, these are some variable like x1, x2, these are some variable, right? So this variables will be converted to a DNA, that is phenotype. So how do we know that how much length will be the length of the chromosomes, or how much will be the length of the string? So for that we have a formula. So how like in this question, here the question is to maximize y, and y is a function of two input variable, one is x1 and x2. Now x1 is varying between x1 minimum and x1 maximum. Similarly, x2 is varying between x2 minimum and x2 maximum. Now we are interested in knowing what will be this length of the DNA. We have x1, we have x2. Now to solve a genetic algorithm problem, we have to convert this x1 and x2 in a DNA or chromosomes or string of some binary numbers, right? So we are interested now what will be this length of the string, that we are interested. So that how we can find out? We can find out by this formula. where L equals log base 2 x1 maximum minus x1 minimum by epsilon, and this x is for L is for x1. Similarly, there will be a L for x2, where L x2 will be equal to same log base 2 x2 max minus x2 minimum by epsilon. Now x1 max you know from the quotient, x1 minimum you know from the quotient. Now the quotient is, what is this? Epsilon. Epsilon is the desired accuracy or the precision. Now every variable like 10.1, this has some precision, right? This the precision, this is actually not precision that you have learned in previous classes. It will have some accuracy, like it is going to 0.1 term, so this will have some this thing is what is called precision. So 0.1 can be called as the precision for this 10.1. so this is known as desired accuracy or precision, and this is denoted by epsilon. So theory, I hope this theory is clear. If not, we will be dealing a numerical example, and by this I will clear your doubt. So I hope the question is visible to all of you. Okay, the question is visible to all of you. Okay, so question is given, binary coded GA is used to solve an optimization problem involving one real variable and another integer variable. So I will tell you the difference between real and integer. The real and integer variables are allowed to vary the range. This one is the range for your real variable, and this one is the range for your integer variable. Why it is called real variable? Because it has decimal points, right? And here it is called integer variable because 0 and 63 are nothing but your integers. So this is your integer variable. Now design a suitable GA string to ensure a precision level of 0.01 for the real variable. So here you can see the precision level is 0.01 for the real variable. Now what is the precision level for integer variable? As precision level is not given for the integer variable, the integer variable has a precision of 1. Kindly noted, the integer variable have a precision of 1. So now we are ready to solve the thing. So let us solve for string 1 or for variable x1. So for variable x1, direct formula is there, logarithmic base 2 x1 max minus x1 minimum by epsilon. Now here you can see x1 maximum is 10.43 and x1 minimum is 0.2. So you can put the formula, and that is log base 2 1023. This is approximately equal to 10. So your GA string for L1 not for x1 will be 10. So similarly we are interested for what will be the string length for x2 variable or L2. So L2, same formula. Here you can see for x2 the maximum x2 max is 63 and x2 minimum is 0. So put it in the formula, x2 max minus x2 minimum by epsilon. Here I have told precision for integer variable is epsilon equals to 1. So 1 you put 63 minus 0 by 1, and you take the log base 2 of this, and you will get approximately 6. So therefore for representation of x1 we need 10. We need a string length of 10 bits, and for representation of x2 we need a string length of 6 bits. So our phenotype was x1 and x2, and genotype it has 10 bits for x1 and 6 bits for x2, and this is a random genotype. I have just written it randomly, and random genotype consists of 1 and 0, so I have just written it randomly. So but it has length is 10 for this and length is 6 for this. So is this sum clear to all of you? Hello? Hello? So anyone, any doubt regarding this question? Any doubt regarding this question? Anyone at any part? Any doubt? Okay, so I think it is clear to all of you. Is epsilon is always 1 for integer? Yes, Jaya. Epsilon is always 1 for integer, not for real variable. For real variable, epsilon value will be given to you. But for integer variable, it will not be given to you, and always you have to take epsilon equals to 1. Okay, Jaya? Okay. So I hope this thing is clear to all. Let me move to the next thing. So now from this, what we got a phenotype for x1, but now we don't know what is actually the x1, right? We just got the string length for x1. So how to get what will be the actual x1? For this you have to apply this formula. So x1 will be x1 minimum plus x1 max minus x1 minimum by twice L minus 1. L is the length of the string, right? So here you see the length of the string is 10. So for x1 you have to put 2 to the power 10 here minus 1 into d. D is the decoded value, right? So here is your this 6. You focus on x2. X2 has 6 bits, right? And it is written as 100111. So if we decode the string, that thing is called d. So let me show you with an example to clear your doubt. So the question is, let x1 be a variable denoted by as GS string 1011. So here GS string is given. So it has 4 bits, right? 1011, and it is varying between 3 and 15. So we have to find the real value for the variable. So hello, any doubt? So there was some discussion, there was some disturbance actually. Okay, so now it is okay. Yeah. So I was telling you this question, right? 1011 is the GS string given. So how to get the decoded value d? Because we have x1 minimum will be 3 here, right? And we have x1 maximum will be 15. And we have L equals to 4 because number of bits here is 4. So if we get this d value or the decoded value for this GS string, we can get the real value of x1. So how to get the decoded value of GS string? So what you do is you start from the right side, very right side. This is your right side, right? You start from the right side, and the first string will have 0 place value, then 1, then 2, then 3. So these are the place values for this GS string, right? So what you do, you do the 2 twice place value into the value of string 2p 2 to the power p into s. Vs is the value of the string. So value of the string here is 1, right? So 2 to the power 0 is the place value here. So 2 to the power 0 into 1. Here the place value is 1. So 2 to the power 1 into 1 is your string value, string bit value. So 2 to the power 1 into 1. Now here your place value is 2. So 2 to the power 2 into 0. And here your place value is 3. So 2 to the power 3 into 1. So you do the calculation. 2 to the power 0 is 1, right? 2 to the power 1 into 1 is 2. 2 to the power 2 into 0, as we are multiplying it with 0, so it will be 0. So 2 to the power 3 into 1 will be equal to 8. You add all this, 8 0 2 1, that will be equal to 11. So your answer will be 11. So okay, not multiplied actually. So x1 will be 3 plus 15 minus 3 into 11 by 2 to the power 4 minus 1. Please check this. It could be wrong because 11 was not multiplied here. Please check the calculations. Otherwise, this will be your answer. Okay? So is this question clear to all? Hello? Is this question clear to you all? How to get the real value of a variable?
Yes, sir.
You got how to decode the GS string, right?
Yes, sir.
Okay, very nice. Anyone, any doubt in this part? Please unmute yourself and ask. It is very important. In your GA calculation, this is the first step and this is very important. So anyone, any doubt at any step in this question, can please unmute and ask. Okay, I hope no one has any doubt. So let me move to the next question. So next is reproduction or selection scheme. So there are two popular reproduction scheme. One is your Rowlett wheel selection and another one is, what is the final answer? Okay, final answer. Final answer, please calculate this. 3 plus 15 minus 3 by 2 to the power 4 minus 1 into 11. Please calculate this. Okay, let me take my calculator. So your answer is 11.8. Srinivas Rao, is it clear? Answer is 11.8. Okay, very nice. So let's move on to the next thing. Is the reproduction scheme. Okay, so we have two very important reproduction or selection scheme. One is your Rowlett wheel selection and the one is rank based selection. So Rowlett wheel selection, how it selects? It selects by probability, and probability will be equal to fitness of an individual divided by some summation of fitness value for all the individuals, or summation value, or the fitness value of the population. So at top will be individual, fitness value of individual, and at the numerator will be population. So that by this you can calculate the probability. So we will discuss by a numerical sum, so it will be more clear to you. So as of now, you just remember this formula. So and second one is rank based selection. So rank based selection, how it selects the term. It selects the term by at the numerator there will be rank. Ri is rank of the individual. And at the bottom will be summation of this rank. Okay, so this will be rank based selection. So let me clear you all with a numerical example, it will be more clear. So here there are 6 string given, or 6 individual population given, and 6 individual is represented, first individual is represented by this GS string 100101. Similarly you can see the second individual population is represented by this second string 011 010, and so on, right? 6 populations, 6 individuals are there in the population, and there will be a binary coded GS string for all this population, right? So here the decoded value is given the fitness value, right? So you can solve the you can find out decoded value for all the population. So here you can see 2 to the power 0 into 1 plus 2 to the power 1 into 0 plus 2 to the power 2 into 1 plus 2 to the power 3 into 0, 2 to the power 4 into 0 plus 2 to the power 5 into 1. You will do the calculation and you will get decoded value as 37, right? So similarly you can find out decoded value for all this individual of this population. So the decoded value is written in this table, and what we have done is we have summed the decoded value. Now your Rowlett wheel selection, according to Rowlett's wheel selection, the selection is done by this thing, by this probability. So what will be the probability? Probability is fitness value of individual population by fitness value of summation of all the individuals in population. So if we do 37 by 200, we will get probability of selection by Rowlett wheel selection, and that will be equal to 0.185. So up to this your Rowlett selection is over. You can try for others also, like for third population we have a decoded value 22, and when we do 22 by 200 you will reach this 0.11. So that is how we select by Rowlett wheel selection. Now how we select by rank wheel selection? For ranking, in this decoded value, you give the rank, and rank will be given according to the smallest value will be given rank 1, and then in ascending order we will be giving the rank. So most smallest is 13, so we have given rank 1 for 13, and after 13 the smallest is 22, so we have given rank 2 for 22. Similarly after that 26, so rank 3 for 26, and so on. Okay, and so on. Like this we have given the ranks. Now according to rank based selection, that will be equal to rank by sigma rank. So summation of all the rank values is 21, and probability of selection by ranking selection will be equal to rank by sigma rank. So 4 by 21 you will do, and you will get 0.190. So is this clear to all of you? Is this question clear to all of you?
Sir, one question, sir.
Yes, yes.
Sir, is it decoded value is equal to the fitness value? How, sir?
Yeah, decoded value is not equal to fitness value. You are right. But in this question, it is given. Particularly for this numerical question, it is given decoded value equal to your fitness value.
But it is a different.
Yes, it is different.
Yes, sir.
Okay, Khushi Kumari is saying again repeat. Okay, let me again repeat. So, Khushi, can you unmute yourself? Hello? Khushi, am I audible to you?
Yes, sir.
Okay, so where exactly is your problem? Can you explain? Can you means point out? So it will be easy for
सर
me to.
डिकोडेड वैल्यू कैसे फाइंड करते हैं?
हाँ, decoded value कैसे find out करते हैं? So in this sum, like here the GA string was 1011, right?
Yes, sir.
Okay, 1011. So you write in a box here 1011. Okay. Hello. Hello.
No, sir.
1011 is your decoded value, GA string, right? 1011. So you write in the form of box 1011. Okay, this step is clear.
Yes, sir.
Then you
Yes,
give
sir.
the place value. You give you start from the extreme right. You give a place value for all this GA string bit. Okay, this one is 1 bit, this one is 1 bit, this one is 1 bit, this one is 1 bit. So you give place value from starting from right. So for extreme right, you give the place value 0. Okay, 0. Then you increase 1, right? So extreme right will be 0, then 1, then 2, then 3. Okay, this is clear up to this.
Yes, sir.
Okay, then
Yes.
the decoded value for each bit is found out by this formula, 2 to the power p into vs, right? P is your place value. Place value for this bit was 0, right? Place value for this bit was 1. Place value for this bit was 2. Place value for this bit was 3, right? So you got the p value you got, and vs is the bit value. Bit value for this is 1, bit value for this is 1, bit value for this was 0, bit value for this was 0. Okay, so if for this bit we will put the formula for this bit, the extreme right bit, so it will be equal to 2 to the power 0 into 1. Okay.
Yes.
Okay.
Yes, sir. Thanks.
Okay, then you find out all this and you add all this 8021, and when you will add 8021 you will get 11. Okay,
Yes, sir.
so I hope this is clear. Similarly in this question also you do the same thing. Okay, 100101, right?
Sir?
Hello.
Sir, in this table, which one is called genotype and which is one called phenotype in this table? You given the string number, no?
This all are called phenotype, right? This all are called phenotype. Okay, and this phenotype will be for a particular variable, for like x1. Okay. Hello.
Okay, sir.
Okay, so Khushi, can you find out for this 100101 decoded value?
Yes, sir.
Okay, so
Thank you, sir.
same type of calculation you do for all the bits, and after you got the decoded value, you do the sigma f. Fi is the decoded value for individual GA string of the population, and when you will do the summation for all, that is called sigma f, and probability of selection for Rowlett wheel selection will be equal to fi by sigma f. So 37 by 200, that will be equal to 0.85. Okay, okay Khushi? Khushi, is this clear?
Yes, sir.
Okay.
Yes, sir, clear.
And then you do the ranking thing. Ranking, how you will do? You will do ranking by from ascending to descending order. Okay, means from ascending order. So you will assign the lowest rank, that is rank 1 for the lowest value. So for 13 we have assigned a rank 1. Similarly, after 13 the lowest value is 26, right? So for 26 we have assigned 22. 22 we have assigned rank 2. Then 26 we have assigned rank 3. So this is your Ri. And sigma Ri, how you will find? Sigma Ri you will find out by summation of all this. So that will be equal to 21. And probability of selection according to ranking selection will be Ri by sigma Ri, and that will be equal to 0.190 for this first population, first individual. Okay, so I hope this is clear. This is clear, right? All of you? Is this clear to all of you? Okay. So I hope this question is clear to all of you, because after this question I will be giving you the larger question. So in that this concept will be helpful to all of you. Okay. So let's move on to the next thing. So we in this slide we have discussed the reproduction scheme. Now we will be discussing the crossover scheme. So popularly there are 4 crossover scheme. One is single point crossover, second is 2-point crossover, third is multi-point crossover, and fourth one is uniform crossover. So what is crossover? Crossover is exchange of bits in the parents to form the offsprings. So 2 parents will participate in reproduction and they will be forming some offspring, right? And in the offspring, by this crossover thing, we are just crossing the DNA of the parents to get the offspring. So this is our first crossover scheme, and that is known as single point crossover. So in single point crossover, what you will do, you randomly choose up to any bit, you are doing the crossover. So here we are choosing after 1 2 3 4 5 6, after 6 bits we are doing the crossover. So we are putting a line over here, and then we are doing the crossover. Crossover means you do the exchange thing. You put here both are 0, so 0 0. Here the parent one will be 1 and parent 2 is 0. So when you will cross over, so you put this 1 for parent 2 and you put this 0 for parent 1. So your offspring will be 0 and 1. Similarly 0 1 here, so crossover this will be 1 0. Similarly 0 1 here, this will be 1 0. 0 0 0 0 1 1 1 1. Okay, single point crossover, is it clear? Hello?
Yes, sir.
Once again, okay, once again. So crossover, reproduction, till now we have done this reproduction. We are just selecting the parents in reproduction scheme. Now in crossover, what we do is we are crossovering the genes of the parents to produce offspring. Okay, so this first one is first scheme is known as single point crossover. So in this, what you do, this parent will have a gene string. Similarly parent 2 will also have a gene string. So what you do, you put an imaginary bar after any string, and up to that you do the crossover for this single point crossover. So in this sum, parent 1 also have 8 bits and parent 2 also have 8 bits, and after 6 bit we have imaginary, we have placed this bar, and up to this so up to 6th bit we will do the crossover. So how we will do the crossover? We will just interchange of bits from parent 1 to parent 2. So here both are 0, so this is 0 0, but here here the parent 1 has 1 over here, and 0 parent 2 has 0 over here. So we are doing the crossover. So 1 will be in position of 0, and 0 will be in position of 1. So in offspring, here you had 1 0, and in offspring you have 0 1. Okay, so
Yes, sir.
okay,
Yes, sir.
is there any rule to fix the crossover point? Jaya, what you want to tell? Can you please unmute yourself? Jaya, are you there? Hello, am I audible, Jaya? Okay, so kindly ask what you want to ask. Please elaborate. After how many bits the red line? Okay, after how many bits the red line is fixed? That is imaginary. You can also take here, or you can also take here. That is up to you. Okay, Srinivas? Okay, okay. So this was your doubt, Jaya. So I hope this is clear. So next thing is 2-point crossover. In 2-point crossover, again here we keep two imaginary bars, and in between these two imaginary bars we do the crossover, right? So we will do the crossover between this red bar and this red bar. So this all the values after this red bar, and all the values before this red bar will be same as it is. We will do the crossover in the middle portion only. Okay, so 0 1 0 1 will be changed to 1 0, 0 0 will be 0 0, 1 1 will be 1 1. Okay, so 2-point crossover, is it clear? Okay, I hope 2-point crossover is also clear. Now we are going towards multi-point crossover. In multi-point crossover, same thing like 1 or 2-point crossover. Like 2-point crossover, you just like in 2-point crossover we put two imaginary bars. In multi-point crossover we will put more than two imaginary bars. And same thing here, like in this portion you will do the crossover, then again in this portion you won't do the crossover. So this portion you do the crossover, this portion you don't do crossover, this portion you will do the crossover, this portion you will don't do the crossover. So is multi-point crossover clear to all of you? Again I am repeating, like in 2-point crossover we are putting 2 bars, in multi-point crossover we are putting more than 2 bars, right? So in this example we have put 3 bars. In 3 bars what you do is at the right side of the bar you do the crossover. So this was your first bar, at the right side you do crossover, and left side you don't do crossover. Now this bar means alternate space you do the crossover. So you start this crossover from this right portion of the first bar. So you are doing crossover here, then you are not doing crossover, then again you are doing crossover, and you are not doing crossover. Okay, so is multi-point crossover clear?
Sir, in multi-point, why we are using the right side? Why we can't use the left side?
Okay, very nice doubt. This I would have explained after some time, but yeah, if the doubt came, let me explain. So the thing is, why we are not in single point crossover also, you are seeing, right, we are doing crossover from the right portion, right, and not from the left portion, right? So why we are doing so? So in explaining you the place value, you see this bit, right? The place value will be small in case of the right side, right? The place value will be smallest in case of the right extreme point, and as we go on the place value increases. So in crossover, what we are doing is we are exchanging the genetic information between two parents, right? But we don't want that the genetic information will be so much change. Means we want some change, but we don't want very much change. So that is why we are starting from the right side. If we would start from the left side, so left side you will get the highest place value, that is 2 to the power 3, right? And in the right side you will get the smallest means smallest value, that is 0. So smallest place value when you will do 2 to the power 0, that will be equal to 1. So for the right one, that is 1, and for the left one, that is 2 to the power 3, that is equal to 8. So for this reason, what we want some genetic information crossover, but we don't want more genetic information crossover. So that is why we are starting from the right side. So is it clear why we are starting from the right side and not left side of the bar?
Yes sir, yes sir. Nice explanation.
Okay, so then is uniform crossover. This one is your last crossover. Means last popular crossover. There are other crossover also, like steady crossover and all, but most of the numerical question come from this 4 crossover schemes. So in this uniform crossover scheme, what you do, you toss a coin for each bit, like this one is your first bit, second bit, and so on, right? So for each bit you so for each bit you toss a coin, right? You toss a coin and let if head come, that is equal to 1 for head, and that is equal to 0 for tail. So in this, when head comes or when 1 comes, what you do, you don't do any crossover, and when tail comes, that is 0, you do the crossover thing. So again I am repeating, for each parent bit you do a toss, coin toss. Okay, so when head will come, head is denoted by 1. So when head will come, you don't do any crossover, and when 0 is coming, you do the crossover. Okay, is this clear?
So is it vice versa or only one? Is it vice versa?
Vice versa means, can you elaborate?
Sir, if it comes 1, we don't change any chromosome.
Yes, if 1 is
Can
coming,
we apply for if it comes 0? Can we change?
yeah. If it is coming 0, like it is coming 0 here, right? This position. So for 3 it is coming 0, right? So when it is coming 0, you do the crossover. So here you are changing 0 to 1 and this 1 to 0. Okay? Hello?
Yes sir, why we can't fix the value when I am tossing value 0? Why I am not going to change the value? Instead of setting 1, if I am setting 0.
Yeah, so you are telling if head is considered 0, you are telling like that?
Yes.
So if head is considered 0, so you do the opposite thing, right? If head is considered 0, it is actually means we are just randomly selecting this rule, right? So you can do the vice versa also. You can form a rule in which h will be 0 and tail will be 1. You can do this also.
We can apply for both 0
or
1. Okay.
So generally this is your rule, but you can also make your own rule also. Okay? When you are programming, you can do this, but in any exam you do this. Okay? I hope this is clear. So now we will be dealing with a GA question. Okay, here everything will be used. like decoding also, your reproduction also, your this crossover also, and also mutations also, and we will be reaching a solution. Okay, so this is your question. Maximize y equals root x, and x varies from 1.0 to 16.0. Okay, so how we will start the question? You will start the question with selecting some individuals in a population. So in this, let's take n equals to, let's take n equals to 6, means we have 6 individual in the population, right? And this is a random string value. Okay, now our next step is to decode this value. So again, like previous sum, you will just decode this value. So 1 0 1 0 0 1, so 2 to the power 0 into 1 plus 0 into 2 to the power 1 plus 1 into 2 to the power 2 plus 0 into 2 to the power 3 plus 0 into 2 to the power 4 plus 1 into 2 to the power 5. So you will get this decoded value, and similarly find decoded value for all the individuals. And when you have all the decoded value, you find the x value. And how you will find the x value? You will find the x value by this. Okay, x1 equals to x1 minimum plus x1 max minus x1 minimum by 2 to the power l minus 1 into your decoded value. So by this formula you will find this x value for the for every individual in the population. So here these are your x value. Now your fitness value is actually the output value. Okay, someone was asking in the previous question that will it be right to have the fitness value as decoded value? In that question it was particularly given, but actually your fitness value is your output value. So fitness value, you got the x value, and fx is your root over x. So you do the root over x for all this. Excuse me, someone is joining. Okay, so you find out the fx value for each of the x value, and you are getting all this fx value or the fitness value. So fitness value, just mark the maximum. So we are getting the maximum fitness value as 3.85 from this calculation, right? And when we are doing the summation, we are getting 17.57. Average was 2.93. Now we are doing here the Rowlett wheel selection. So we are doing here the Rowlett wheel selection reproduction scheme. So Rowlett wheel selection, as I have already told, that will be equal to Fi by sigma f. So you can find the selection value for all this individual in the population. So these are your probability of selection values, right? And then what you do this expected count. So the thing is, if you find the Rowlett wheel selection value, you will have all these values very close to each other, like 0.18, 0.15, all these are very close to each other. So particularly we can't use this value for selection. So for this we are adding one extra column, that is Fi by f bar. F bar is your average value. So when you will do the Fi by f bar, you will get all this value for your individual population. So you are getting 1.07, 0.91 and all this, you can see this. Now according this expected count, what you will do the actual count. So you just approximate it. We have 6 values, right? So here you are getting 1.07. So let selection for this is 1. Now again 0.91, again you do 1 for it. Now 0.85 is actually less for it, so let it be 0, and 0.69 also let it be 0. So we are remaining with this two, 1.31 and 1.16. So let's put 2 over for all this. So this is what is written in your actual count. For first we have taken 1, then again we have taken 1 as third value was 0.85. 0.85 is actually smaller, so we have eliminated it, or we have written 0 for it. Similarly, last value was 0.69. Again we have eliminated it and written 0 for it, and other two we have given 2. So if you will add this, you will get 6. 1 1 0 2 2 0, right? So now all this value will form a mating pool, means all this string individual values will participate in a reproduction. So they will form a mating pool. So as for first value, your actual count was 1, so we have written the first individual here. For second individual, again the expected count was 1, so again we have written the second individual. Now what went for third individual? For third individual, the actual count was 0. So for third individual, we are eliminating actually third individual. Similarly, for sixth individual also, the actual count was 0. So we are again eliminating the sixth individual also. And for other individual, fourth and fifth, we are taking it twice, right? Because actual count was twice. So for you can see, for fourth individual, we are repeating this. These two values come from your fourth individual. Similarly, these two values came for your fifth individual, right? And we have eliminated second individual and sixth individual, right? Then we have to form a mating pair for all this. Now this is your mating pool, but we don't know which two individual will form parents, or which two individual will be participating in reproduction. So for this we will be doing a mating pair. Now how to do the mating pair? Now according to reproduction, we know the offspring will be strong when two different individuals reproduce. So we will see for this first individual what will be the most different type of individual. So our first individual has been 1 0 0 1 0 1, right? And the most different individual for this first one is, you will see here this is also different, but we can take this third individual as the mating pair for this first individual. So we had written in front of 1 we have written 3, right? Then second individual has in front of second individual. For second individual we found sixth individual was very different. So for second individual we have mated it with sixth individual. Similarly we will do the rest, right? So by this mating pair we got the parents, right? So one will be reproducing with the third one. So we have written 1, this one is 1, and this one is 3. Similarly 2 and 6, and remaining 5. This one is your fifth individual, and this one is your fourth individual. right? So we have formed parents, or we have formed a mating pair for this, and after this mating pair, what we are doing, we are doing this crossover. And crossover, we have just I have just explained you, you just exchange the bit between the parents. So these two are parents, right? So you do the crossover here, and crossover imaginary bar is taken after this fourth bit. So after that fourth bit, so sorry, before that fourth bit, you do the single point crossover. So this two, right? Okay, this two. Okay, okay. Here are your children's, right? So 1 0 when you are exchanging, that is 0 1. Similarly 1 0 you are exchanging 1 0, 1 0 you are exchanging 0 1, 0 1 you are exchanging 1 0. So this are your parents and this are your children. So 2 pair, this 2 pair, this 2 pair, and this 2 pair. So you are getting 2 children here, 2 children here. And after that, last thing is your mutation. Mutation, what you do is mutation, you just change a bit. Mutation is change of biological property. So don't do mutation excessive. In GA, mutation is always done for very small points. So in that is 1 2 3 4 5 6. In this 6 into 6, that is in all this 36 bit, we are only changing one bit. So this one bit is mutated. Here you can see this one was actually 0 here, but now it is 1 here. Okay. So this is our result, and by this you can again do the decoded value for this. And when you will decoded value, and after decoded value, you find the x value. Now here when you find the fitness value or fx after one iteration, this is called one iteration, because we have done one step. So this is your after one iteration result. So after one iteration, you will get this results. So what has changed here? See, here the maximum value was coming 3.85, right? But here the maximum value has changed to 3.91. So this is how GA work. So is this thing clear to all of you? Any step, any doubt? Hello? Are you guys here? Hello? Am I audible? Okay.
Yes, sir.
Okay, yeah, ask.
From the
Hello, please
sir, I'm
ask.
audible, sir.
Yes, please ask.
Sir, roller pill and order selection, which one is the best, sir?
I am not getting your question. Can you be a bit louder?
Sir, roller pill and order selection, which one is the
So you are asking which reproduction value to use, which reproduction scheme to use, Rowlett or ranking selection, right? This is your doubt?
Yes, sir.
Yeah. So you,
Yes, sir.
if it is not given in your question, you can probably use anything. Okay. But if it is your given in question that use this reproduction scheme, then you have to use this particular reproduction scheme. It is up to you. Okay. If it is not given in the question, it is up to you. You can use anything of the two. If it is given in the question, you use that. Okay, Jaya, Navneetan, in mutation can be changed 2 bit at a time or only one bit at a time? Okay. So Jaya, the concept here is you mutate very few bits. Okay, you can mutate 2 bits. You can also mutate 3 bits. But the logic here is as much low mutation you can do, that is more acceptable. Then if you are doing maximum mutation, it is not acceptable. So please mutate as less as possible. Okay. Okay, Jaya, and another thing, actually in some question you would be given a thing called this mutation probability, or PM. So if this mutation probability is given, like if it is given as 0.001, right? So 0.001 into 36, 0.001 into 36 is your 0.036. So 0.036 bits means not even 1 bit. So here you don't do any mutation. So Jaya, if this mutation probability is given PM, then you can multiply this mutation probability with your total number of bits, and whatever the answer is coming, you change that much, you approximate it and you change that much bits. Otherwise you change as less bits as possible. Okay. Okay. Any other doubt apart from this? This is your whole GA question. So any step, any doubt, kindly ask. Any step, any small doubt also you can ask. I can probably again repeat if you will tell. Any small doubt also you can ask. Is there anyone, any doubt? Okay, so if no one has a doubt, can I ask why we have taken this population equals to 6 or number of bits equals to 6? Why we have taken so? So here in this question we have taken at random. Okay, so if it is given that you take 10 individual in a population or 12 individual in a population, you have to do that. And regarding number of bits, if your epsilon value is given or your precision value is given, then you put this formula. Okay, you put this formula. You put this formula and calculate number of bits. But here, as your precision value is not given in this question, so we have assumed let number of bits equals to 6. But if this epsilon value was given in the question, we first needed to do this calculation to have number of bits, or L equals to what? Okay. Is this part clear to all? What I have explained? Hello? Am I audible? Hello? Guys, am I audible? Okay. So I hope this question is clear to you all. Any doubt? I am again giving you 1-2 minutes. Kindly ask any doubt in that question. Please ask. 2 minutes I am giving you more. Any doubt, any part, please ask. This is most important GA question, covering all this decoded value thing, fitness value thing, and all reproduction, crossover, mutation. It is covering all. So any doubt in this question, kindly ask. Okay, so I am assuming nobody has any doubt in this question. So let's move to the numericals. So numericals in this week will be discussed from this topic. GA operator and numericals not assignment question. Similar to your assignment question will be discussed, and this question will be discussed on all these 5 topics: GA operator encoding 1, GA operator encoding 2, GA operator selection 1, selection 2, and GA operator crossover. So this is our first question in real value encoding, which is the correct form for representing a gene. Option A is in the form of tree or object. Option B is in terms of bits. Option C is in terms of values or string or symbols, and option D is in terms of sequence of elements. Okay, Jaya Navneetan is telling B. I encourage everyone. Okay, Khushi is telling once again repeats this question, sir. Okay, Khushi, can you tell at which portion particularly you have doubt? Khushi, am I audible?
Yes, sir.
Yeah, which
Yes,
portion?
sir.
Which portion you have doubt?
Sir, next slide.
Next slide, yes. Next slide, which portion?
Sir, mating pair.
Yeah, mating pair, right? Mating pair. So in mating pair, the concept, how we form mating pair? We have this 6 population now, right? We have this 6
Yes, sir.
population now, and they will be forming parents. They will be forming parents 2 to 2 to 2 2. Means we will have 3 parents, right? Means 3 set of parents. 3 set. Now the concept of gene evolution, or the concept of all our evolution that had taken place, it tells us that reproduction will be best if the reproduction is between 2 different type of individuals, right? So it will give you a strong offspring if the reproduction will be performed between 2 different kind of individual. So we have this first individual 100101. So so what you do is you search the most different individual. So most different individual, in term of bits, you can also take this as parents. Also you can take the third as parent. Okay, so for first, the most different of it, this, see, first and fourth we can do, because one is same here, and we have some similarity over here. So you can reproduce first with either second or first with third. Okay, because these two are looking different from each other. So that is why we have formed the mating pair between 1 and third. Okay, similarly we have formed mating pair between 2 and 6. Similarly this 2 and 6 is over, then 5 and 4. Okay, okay, Kushi?
No, sir.
Okay, so mating is done between 2 individuals that are very different from each other. So you focus on this individual. It has bit 100101. Okay, so the most different from this bit is your second one or your third one, right? Fourth one is kind of similar. If you will see fourth one, then this one is matching. So what you do is you do mating with most different. So most different is either your 2 or your 3, right? So in this question what I have done is I have done mating of 1 with 3. Okay,
Yes, sir.
okay, similarly
Okay.
you do for other also. 1 and 3 is over. Then for second we have found the most different of second is 6th. Okay, so we have mated second with 6. Similarly we have mated 5th with 4. So we have mating pair 1 3 2 6 5 and 4. Okay,
Yes.
these are your parents, and then you do the crossover thing, and then from crossover we will get the children by this crossover, single point crossover here, and then mutation. Okay,
Okay, sir.
okay, so move to the question. This was the first question, and some of you have told B, some of you have told C. So any other guesses? I encourage everyone to answer this question. You can write in chats. Okay. So any other option you are guessing apart from B and C? Okay, so your answer is C, because in terms of bits, actually it is in terms of bits, but in terms of gene, we write genes in terms of string, right? In string there are bits like 1 0 1, right? And in terms of this binary also there are some other type of problem. In there we can have symbols also like alpha, beta, etc. So your answer will be C. So again I am repeating, in real encoding value, in real value encoding we express our variable, or we express our phenotype in the form of genotype, and your genotype will be in the form of strings, or strings containing bits or symbols. So your answer will be C. Okay. So let's move to the next question. Which encoding scheme is faster? Binary encoding, real value encoding, tree encoding, or D, all of the above required same time to execute? So guys are telling A. Very nice. So any other guesses apart from A? Okay, so yes, the right answer is A. So here as the computer only understands 0 and 1, so if you will write the bits in form of 0 and 1, the encoding will be much faster. So here binary encoding is faster among all these three. Real value encoding you have to first change to binary encoding, and then you have to do the encoding. So it has one extra step. Tree encoding you have to cut the branches of trees, and in tree then you have to do this real encoding, and from real encoding you have to do the binary encoding. So it has two more steps, tree encoding. So binary encoding is your fastest one. So answer is A. Okay. So let's move on to the third question. The purpose of fitness evaluation is A, to emphasize the fittest individual of the population, B, to generate new population, and C, to ensure the survivability of each individual in the current population, and D, none of the above. Yeah, Jaya is telling C. Anyone else? Yeah, Murugesan D is also telling D. Sorry, C. So anyone else apart from this C option? Okay, so yeah, the answer is correct. Your correct answer is C. The fitness evaluation is done to evaluate survivability of each individual in the current population. So we have just done a numerical example. So let me tell you by this. So see here you can see the fittest individual among all this is 3.85. Okay, fittest individual all of this is 3.85, and expected count for this 3.85 is 2. But on the other hand, the unfittest individual was your 2.02, and expected count for 2.02 was 0. So when the expected count of 2.202 was 0, so we have just eliminated it. So we have just crossed it. right? Actual count, when we have done the actual count Rowlett wheel selection, we have just crossed it, right? We have just eliminated it. So the individual which has the best fittest value, it survived, whereas those which like 2.02, which has the least fitness value, it doesn't survive or it eliminated. So this is the concept of your this question number 3. So is question number 3 clear to all? Is question number 3 clear to all? Can I get the response? Hello, am I audible? Yeah, Jaya is telling yes. So I hope the question number 3 is clear to all. Again, I am repeating, the purpose of fitness of individual is to evaluate survivability of each individual in the current population. In the numerical question we have just seen, is 2.02 was the least fittest value, and after we were doing the Rowlett wheel selection, it didn't survive, right? So that is the importance of the fitness value evaluation. I hope this question is clear. So let's go to the fourth question. Rowlett wheel selection strategy suffers from which of the four? A option is high computation time, B is lesser diversity, C is premature convergence, and D is none of the above. So anyone who wants to have a guess for this one? Yeah, Murugesan D is telling B. Anyone else apart from this B option? Okay, so let's see the answer. Actually, the problem with Rowlett wheel selection is individual with higher fitness value will guard the other to be selected for mating. As we have seen, the individual which has highest fitness value, it was I think 2.85 or something. The individual which has fitness value 2.85 or something, means the highest fitness value, it is in the selection twice, right? And individual with lowest fitness value like 2.02, it got eliminated, or it has got selection 0 time, right? So this is the concept. So for this thing, higher fitness value has guarded this lowest fitness value term. So for this, this leads to lesser diversity, as the individual with lowest fitness value is eliminated. So diversity is less, and hence there is a fewer scope towards exploring alternate solution, and also premature convergence of early convergence with local optimal solution. So what happened is, if there is a optimum solution, like if we are interested in finding minima of this term, so here if like here the answer was 2.02, right, and here was 2.85. So we can see in this graph, according to our question, this 2.02 will be wiped out, but this 2.02 is actually a local minima for this portion of your graph, right? So this is known as premature convergence problem. Like one part of your graph will be wiped out. So these are the two things that Rowlett wheel selection suffers. That so your answer will be B as well as C. So answer will be B and C both. Okay. Jaya, is there any doubt? Hello.
Sir, one doubt, sir.
Yes, yes.
Sir, actually in Rowlett wheel we are giving the higher priority for the best solutions.
Yes, yes.
How we can say that solution is called premature convergence?
Premature convergence. Premature convergence, like in this graph I am telling, like if there is a local minima problem, this graph can be like this also. Okay. So if your Rowlett wheel selection is giving is only pointing one point, other point will be wiped out, one part of the graph will be wiped out. So this is actually called premature convergence, means this is telling minimize this point or only this point. So this is known as premature convergence. Okay. Like it is not
Sir, actually,
giving you the full solution. Like it should have told you that at this portion of the graph this is your local minima, and at this portion of your graph this is your local minima. It should have told you the complete story, but here it is not telling you the complete story. So this is your premature convergence or early convergence. Okay. Hello.
sir, actually in the out of 6 population, initial population, we will call it as only one solution is best solutions.
Yes, yes.
Among that 6 solution, initial solution, only one solution is best solution. So we choose from the Rowlett wheel.
Yes.
How we can call that solution is a premature solution? That is my question. In generally we can call there is a n number of local minima is available.
Yes,
I
yes.
accept that, sir. But instead of that, only the particular that 6 initial solution we can call it only one solution is the best solution. No.
Yes, one solution is the best solution. Yes, we were interested previously in maximization thing, na? Here only I have taken the example. This is has not. This is just an example. This does not relate to that. There you were asked to do the maximization thing. You were told to do maximization between 1 and 15. The function was y equals to root x. So there you had to do the maximization thing. Okay. So this is just an introductory example for you to explain this thing.
Okay, okay, sir. Okay, okay.
Okay.
Is the general advantages of general limitations of Rowlett wheel's premature convergence?
Yes, yes, yes.
Yes, sir. Yes,
Yes.
sir. Okay, okay, sir. I understood.
Okay. So question number 5. Which crossover technique suffers from positional bias? So these are your four options. You must have studied this concept from your lecture note. So anyone who wants to have a guess? Yeah, someone is, Jaya is telling C, Murugesan D is telling C. Anyone else? Pralaya is telling B, okay. Any other options? Okay, so let me tell you the question. So this is the thing. So in binary crossover, it suffers positional bias because here you can see the thing. Here you can see the thing that for this positional bias, right? Yeah, positional bias. Like if you have to go from 11 to 12. So binary for 11 and binary for 12. Binary for 11 is 11. So binary for 11 is 1 1 0 0, and binary for 12, when you will see, then 12 1 1 0 12, right? Two to the power 0 0, 2 to the power 1 1, yeah, it is 1 1 0 0, and here you can see 0 0. Okay, so let me take this 9 thing, 9 twice 4, one zero zero 1. So yeah, so when you are comparing 9 with 11, for 9 for 9 your position was sorry, your bits was 1 1 0 0. Sorry, for 11 your 1 1 1 0 0, and for 9 it was 1 0 0 1. So here you can see we are just moving two places in our real variation, whereas in binary our three values are changed. Like this bit also changed, this bit also changed, and this bit also changed. So this is known as positional bias. So to avoid positional bias in binary crossover, we use some other type of crossover known as gray crossover. So you can read more thing in detail, but as of now I just want to explain you that there is much variation in going from one real value to another real value in when you are exchanging in binary thing. So that depends on location of the bits in chromosomes, right? So to avoid this, in place of binary crossover we use gray crossover. So your answer is C. Okay, so again I am repeating, what happens is, in binary crossover your crossover strongly depends on position of bits of the binary thing that you have that you have encoded from the real value. So in binary what you will see, when you are going from one value to another value in real variable, in binary there is massive change. Like in real we have just two position change in going from 11 to 9, but in binary we have 3 position change. And when we have so much position change, when we are doing crossover things, there are some abnormalities in your solution. So this is known as position bias problem in binary crossover. So to avoid this we use gray crossover. Okay, so is it clear? Hello, is this thing clear to all of you?
Yes, sir. Okay, sir.
Hello.
Yes, sir. Yes, sir.
Okay. So let's move to the next thing. The drawback of Rowlett wheel selection is rectified in which selection strategy? Option A is tournament selection, B is steady state selection, C is canonical selection, and D is rank based selection. Kindly guess the answer, guys. So any guesses for this? This question? Okay, D. Any other guesses? Okay, so let me quickly tell you that yes, D is the correct answer. Rank-based selection is expected to perform over this Rowlett wheel selection, because unlike in Rowlett wheel selection, I have told you the drawback. One is your premature convergence. Second is lesser diversity. But when you are doing the rank-based selection, what you are doing is you are providing rank. You are not eliminating as such. You are not eliminating any terms. Which has the lowest fitness value, you are given a probability to it, like this fourth one in the diagram has lowest fitness value, you are giving a probability for this, like 10%. You are not eliminating the thing. So a rank based selection expected to perform better than Rowlett wheel selection. So your answer is D. Okay, any doubt over this? Any doubt regarding this question? Okay, let's move to the next question. Which of the following cannot be constraint of traveling salesman problem? So these are the four things. Visit all cities, one city only once. C is starting and ending city is same, and D is order of traversing is fixed. So anyone who wants to have a guess for this one? Okay, G2 Nayak is telling A. Anyone else? Anyone, any guesses for this? This thing is given in your lecture note, this traveling salesman problem. So yeah, D. Murugesan D is telling D. Anyone else? Okay, so your answer is D. And how this is your traveling salesman problem. What traveling salesman problem is telling? Traveling these points are denoted for all the cities. So this point, all the individual point represent one city. So in traveling salesman problem, these are the three constants. You have to visit all the cities. Second is one city should be visited only once. Right, one city should not be visited more than once, because if one city will be visited more than once, it will have unnecessary time wastage as well as wastage of resources. So again, one city should be one city should be traveled only once. And the third is starting and ending is same. So if you are starting from a one city, the thing is you have to reach this city only. So if I am marking 1 for this, what you have to do is you have to go to all the cities, and you have to ultimately reach to this city only. So this I am this I have only drawn to just explain you. So the thing is starting and ending city should be 1. So this is your starting as well as ending city, this one. So in this you can see order of traversing is not fixed. Not fixed means after here you can also go here also. That means it is not mandatory that after here you only have to go here or you only have to go here. So order is not fixed, order is variable. Okay, so order is variable. So I hope you get this, everyone. Is this question clear? Guys, is this question clear?
Yes, sir.
Okay, okay. Now, next question. Which of the following crossover schemes use a binary crossover mask? So, anyone who wants to have a guess for this question? A is multi-point crossover, B is your uniform crossover, C is your shuffle crossover, and D is your single point crossover. So anyone who wants to have a guess for this question? Okay, G2 Nayak is telling A. Anyone else? Yeah, Murugesan D is telling B. Anyone else? Okay, so let me tell you the option. So uniform crossover is your answer, and uniform crossover, that tossing of coin is also known as masking. Means you are providing a mask, and in this mask you are deciding that whether you have to cross over at 1 or at 0. So this tossing of coin is also known as masking. So your answer is uniform crossover. So that question, I hope this question is clear to all of you. This one is a easy question, so I am quickly moving on to the next question, assuming that is clear. So what will be the binary representation for x equals 10 with 4 bits, where lower value of x is 2 and upper value of x is 17. So anyone who wants to have a guess for this one? Okay, so let me tell you the answer. So yeah, here again, and that xl or x minimum is given 2 or x maximum is given 17. Okay, and here you have to do x equals to 10 with 4 bits. Okay, so 4 bits you have to for x equals to 10, you have to find the value of x equals to what? So x you can find by that formula, that is x minimum plus x max minus x minimum by 2 to the power l minus 1 into decoded value. So decoded value already is given, that is 10. So decoded value you put and you found the x value. Now we are actually given our option in terms of binary bits. So our answer is actually 12. But how to express this 12 in binary bits? So 12, what you do, you divide the thing with 2, and you write the remainder at this point. So when you are dividing 12 by 2, that is 6. Again you are dividing by 2, that is 6. Again you write 0. You again divide this 3 with 2, you will get quotient 1 and remainder 1. You divide this 1 with 2, you get quotient 0 and remainder as 1. And you write this thing in the form of this binary representation. So your binary representation will be 1 1 0 0. Is this thing clear? How to convert a real value in binary value? Is this thing clear?
Yes, sir.
Yeah, so your answer will be D. I hope this is clear, how to convert a decimal in binary. Again I am asking, anyone, any doubt regarding this thing, please ask. How to convert, again I am repeating, how to convert a decimal value into binary. You divide it by 2 and you write the remainder, and when 12 is divided by 2, the remainder is 0 and you get quotient 6. Now that quotient you again divide by 2. When you are dividing it by 2, you will get 0. Similarly, you do for the other thing, and you write all the remainders from right to left. This is very important. You write all your remainder value from right to left. Okay, so your answer will be D. So let's move to the next question. Question number 10, in which selection strategy an individual may get selected more than once. So anyone who wants to have a guess for this question? Are you guys here? Am I audible? Okay, Murugesan D is telling D. Jitu Nayak is telling A. Murugan is telling D. Anyone else? Okay, so your answer is actually B as well as D. So Rowlett wheel selection I have already told you, and in tournament selection also we do the tournament, and when we do the tournament, what we do is we actually select one fittest individual and one less fittest individual. So in tournament selection also, your one individual can get selected more than once. So your answer is B as well as D. So B as well as D. Again I am telling, in tournament selection what you do, you arrange a tournament, and you do tournament with fittest value and one less fittest value. So in tournament selection also, here if I will tell this F, this is fittest and this is less fittest, LF. So in tournament selection also what happens is fittest value gets selected more than once. So your answer is B as well as D. Okay. Okay, so let's move on to the next question. Find the decoded value for the string 1010. So can I get a response from all of you regarding this question? This is a very simple question. I want everyone to participate in this. 1010. What will be the decoded value, guys? Yeah, Murugesan D is telling C. Anyone else? Yeah, Jaya is also telling C. Kindly others also please participate in this question. Okay, so let me tell you the answer. So answer will be 0 into 2 to the power 0, that is 0, plus 2 into 2 to the power 1 into 1, that is 2, plus 2 to the power 2 into 0, that is 0, plus 2 to the power 3 into 2 to the power 3 into 1. So answer will be 10. From this string, from this bit we are getting value 8, and from this bit we are getting value 2. So 8 plus 2 is 10. So answer is C. So I hope this is clear. So let's, what is canonical selection?
Yes, sir.
Yeah, canonical selection. Canonical selection you can probably read it from your lecture note only. Okay, Murugesan? Hello? You are provided a lecture note, right? So kindly read it from your lecture note only. You will get detail. Actually, the most popular are these two, rank-based selection and Rowlett-based selection. So that is why I have not discussed canonical selection here. Okay? You can probably go to your lecture note and read it. And if you have any doubt regarding canonical selection, you please let me know in the next class. Okay?
Okay, sir.
Okay. So this is question number 12. To overcome this binary code related problem, which coding scheme is evolved? I have answered this question previously also. So I want everyone to have answer for this. Yeah, gray coding. Anyone else? Yeah, so I have already explained this thing regarding your the previous thing also. Here, when you are changing from when in real variable, when you are taking a small step in binary variable, a binary string, the changes can be massive. So to avoid this, this problem is also called as Hamming-Cliff problem, and to avoid this, what we use this gray coding. So I have already discussed this, so let's move on to the next question. Which one is the correct statement for the tournament selection? A is population diversity is low, selection pressure is high. B is population diversity moderate, selection pressure high. C is population diversity is high, selection pressure is low, and D is none of the above. So anyone who wants to have a guess for this? Anyone who wants to have a guess for this? Okay, so this question you can find in the lecture note only. So there are 4 things that are compared here. One is Rowlett-Weill selection, rank selection, tournament selection, and steady state selection. So here it is written for tournament selection. So in tournament selection, what happens is population diversity is moderate and selection pressure is high. So here you can focus. So your answer is B. So this thing you can probably read it from your lecture note. This is not a numerical problem, so I am not fully discussing it, but you can have this table from your lecture note and you can see this. Okay. So I am not wasting time on this. You can probably see this, find this in lecture note. So question number 14, which of the following is not a GA encoding scheme? Graph encoding, real value encoding, binary encoding, or order encoding? So anyone? Murugan is telling A. Anyone else? Any other option? Yeah, G2 is telling C. Okay, so actually G2, whatever we were doing was binary encoding. So your option C is not correct, because whatever we are doing, actually it was called binary encoding. So option C is wrong. Option A, graph encoding, is the correct. Other 3 are your encoding scheme. Real value encoding I have already discussed in terms of binary encoding already seen. Order encoding you can probably see from the lecture note only. So graph encoding is not a encoding scheme. So here A is your correct answer. Okay?
Okay, sir.
Okay, so last question, which one is right order for GA operation? So I want everyone to guess this, because this is the last question, and numerical question also I have discussed based on this. So I want everyone to guess this. Yeah, Murugan is telling D. Any other? G2 is telling C. Okay. Anyone else? I encourage everyone to participate in this. This is the last question. Also I have discussed the numerical question based on this. Bharati also is telling D. Anyone else? Okay, so yeah, the option D is your correct answer. So that question also we can probably see from that question also. Yeah. So in that question, whatever we have done, this thing is called encoding. We have our binary string. This is called encoding. Then after encoding, what we have done? Encoding. I am denoting it by E. This part, right? So this is known as encoding, right? And this is known as fitness evaluation. F E. these are your fitness values. So this is your fitness evaluation. Then this part is crossover. This part was your reproduction, mating, where mating is performed. This part your reproduction, and this part your crossover, and this is your mutation. So the correct order was encoding, fitness evaluation, reproduction, crossover, and then mutation. So your answer D is correct. So I hope no doubt regarding this question. Right, no doubt regarding this question.
No, sir.
Okay, so anyone, we have actually completed our session. Anyone, any doubt regarding today's session? Can please ask.
Sir, I have option there.
Any other doubt?
Hello.
Yes,
Sir?
yes, please.
Sir, I have one question.
Yes.
What's the need of choosing the
Your
NPTEL population?
your voice is not coming clear. Can you again repeat?
Sir, is there any limit? Yes, sir.
Yes.
Sir, what is the limit of choosing the initial population?
What is the limit of choosing the initial population? So in all this numerical question, what you do is you keep the population below 10 only. Okay, for to have simplified calculation. In when you are doing your that programming based thing, there you can vary and can see the result. Sometimes the result come good in less number of population also, like 100 also you can get result. Also in some complex type of problem, your problem can go up to 1000 populations also. So it depends based on complexity of the problem. You choose your initial number of population. But when you are solving a numerical problem, there you choose population less than 10. Okay.
Sir, can we expect if we are choosing the higher population, more optimized result?
No, that is not correct for every thing. Actually, what happens is it is an optimization thing, right? Optimization is what? Optimization is finding best solution of all the possible solution. So it is not true that if the number of population is increased, then you will get more optimized value. That is not true, because sometimes what happens is these are iteration based calculation, right? So sometimes what happens is you get a maximum, you get the most means best value at a population, like you get the best value at 100. After that your value is not increasing. Like if you want to maximize it, there the value is stopping, or the graph that you are achieving. Let me explain you. The graph that you are actually achieving, that can be like this only. Okay, so after this, like if this is your iteration, I am denoting it by I. So if after this I equals to, let's say, 100, after this 100 your value is not increasing. This is your let's say fx. Okay, after this 100 iteration, not iteration, it is number of population n. Okay, so after that 100, if you are increasing population beyond this 100, our value is not increasing, it is coming to a halt. Okay, so so that is why we have to choose a number of population according to optimization thing. Okay, so if here we are increasing our population to 1000, what will happen is the fx value will be same, but your computational time is increasing. So we don't want increase in computational time also, right? We have to keep these two things in mind. One, we have to reach this optimum value, and second we have to reach this optimum value in a limited amount of time. So for keeping this two in mind, we select the number of population. Okay. Hello.
Yes, sir. Very good, sir. Sir, one more question, sir. Sir, as per your suggestion, what is the application of genetic algorithm in engineering field as point of view?
Optimization only. Like this question.
What?
This question, optimization is what? Finding the best possible solution out of all the solution. Like this question only.
Sir, an engineering problem.
Yeah.
Where is that?
Yeah, engineering problem only. Like this is your equation. This equation can be based on any graph. Like this is your input variable, right? This is your I1. Let's put I only, and this is your output O. So either you do the either you do means the theoretical calculation, or you find it out by GA. So if this is a very simple equation, right? Y equals to root x. If your equation is increased by other terms also, like x2, right, x3, and so on like this. If you had many number of inputs like x1, x2, x3 out of up to xn. Okay, so in this
Sir,
case you can't do your mathematical calculation well, right? So in this case, what you do, you form a GA string and you program it and find the output. So that will be more easier. Okay. So this x1, x2, x3 are your inputs. That can be any engineering input. Like if your process, if you had a process, like you have to measure heat, and this heat depends on temperature. This heat also depend on humidity. This heat also depend on some other time also, right? So this is your output. H is humidity is your output, and you have three input. One is temperature, and there is this H humidity, and the one is T time. So you have three inputs, and on these three inputs your humidity is depending by some equation. Okay, so in this you can use GA. Okay, so like this you can use it in any engineering problem. Okay.
Okay, sir. Okay. Thank you, sir. Thank you for answering all the questions, sir.
Oh yeah, it is my pleasure.
Thank you.
Okay, so anyone else, any other question? So we have already exceeded 13 minutes, but other 2 minutes more. If anyone has any question, they can ask. I will terminate this session at 8:15. Okay, anyone any other doubt? Please ask. 2 minutes more I am giving. Anyone any other question can ask. Okay, so I think no one has got any doubt, so I am terminating the session. Thank you all. We will meet on the next Tuesday, same time, 6 to 8 p.m. Okay?
Okay, sir.
Okay, so bye guys. Okay.